Welcome to the deep dive. Today, we're diving into something pretty fundamental, but often invisible APIs, application programming interfaces.
That's right. They're like the hidden plumbing connecting different software systems. They let apps talk to each other, share data.
Basically, the rules of engagement for software components, telling them how they can ask each other for things, right?
Exactly. And we're going deep specifically on API testing. Now, this isn't about how an app looks or feels.
No clicking buttons or checking menus
Nope.
here.
That's user interface or GUI testing. API testing goes straight to the business logic, the engine under the hood.
Yeah,
We use software to send calls directly to these APIs,
okay.
see what output we get back, and then crucially analyze if the system's response is what we expected.
And free listening, look, understanding how software talks behind the scenes is actually becoming super relevant.
Oh, absolutely.
Whether you're just curious about how your apps work, or maybe you need to talk tech with colleagues, or just, be more digitally savvy, API testing is what ensures these hidden connections are actually working properly, that they're functional, reliable, fast enough, and secure.
Definitely. And for this deep dive, we've looked at some really insightful material, mainly drawing from an article that breaks down API testing really well.
So our mission today,
To pull out the core ideas, what is API testing, why is it so vital, and how do the pros actually approach it?
okay, sounds good. Let's get into it. So if someone wants to start testing an API, what are the bare minimum requirements? Where do you begin?
Well, fundamentally, you need two things. First, an application that has an API available for testing.
Makes sense.
And second, you need a way to actually interact with that API. That could be a specialized testing tool, or sometimes people write their own, custom code to send those requests.
Right. Now, the article hinted it's not always straightforward to set up. Something about configuring databases, servers, it sounds a bit more involved than just opening a web page.
It definitely can be. Setting up that testing environment often requires interacting with the backend infrastructure.
Okay.
You might need to get databases ready, configure servers, make sure everything's aligned before you can even start calling those API functions to check if they work correctly. It's a different beast than GUI testing.
So once you've jumped through those hoops and you send a request, what kind of answers or outputs can you actually get back from an API? The article mentioned a few types.
Yeah, the responses vary. Sometimes it's just any type of data. Think of a simple function, maybe an add function.
Okay.
You send it two integers, say 5 and 3. You expect it to return the data 8.
Simple enough.
Right, but the test isn't just checking if it returns something, but if it returns the correct something, the expected outcome. And you also need to test edge cases, like what happens if you give it numbers that are too big? Does it handle that exception gracefully?
Ah, good point. So error handling is part of it too.
Yeah.
What about when it just returns a status, like pass or fail?
Exactly. Some API functions are more about actions, things like maybe lock a record or unlock or delete.
Right.
These might just return a simple Boolean true for success, false for failure.
So how do you test that properly? Just trust the true.
Well, you check the return value, but often you need to verify the side effects. If you call delete, did the record actually disappear from the database?
Ah, okay.
You might even need to check the application's front end, the GUI, to see if the change is reflected there. So the verification can go beyond the API response itself.
So the ripples can spread, and that ties into the third type of output, right? Calling another API event. One thing triggers another.
Precisely. APIs often work like orchestrators. One API call might be designed to kick off another process or API call.
Can you give an example?
Sure, maybe deleting a user account through one API call automatically triggers another API call that refreshes the active user list in the system.
Okay, a chain reaction.
Exactly. So testing that involves checking the initial call worked and confirming that the subsequent expected call or event actually happened downstream.
Right, so you need to trace the whole sequence. Okay, that gives us a good feel for the setup and the kinds of responses. But how do you actually design good API tests? What should testers be talking about?
That's really the core of it. The article lays out some key considerations. First, obviously, verifying the return value based on the input you sent. That's often the most straightforward part.
Like checking the sum in our ad example.
Correct. But then, you also need to figure out how to check the API's behavior on the system when there isn't a direct return value, or when the return value isn't the whole story.
Like our delete example, again, needing to verify the deletion elsewhere.
Exactly. Then there's tracking those subsequent events or interrupts. If calling API A is supposed to trigger process B, your test needs to confirm that B actually started.
Makes sense.
And very importantly, You need to authenticate the outcome. If the API call was supposed to change data or modify a resource, did the change happen? Was it the correct change?
So it's really about verifying the entire transaction and its consequences, not just the immediate reply. The article also mentioned a sort of general approach or workflow for API testing.
It did. It generally starts with really understanding what the API is supposed to do, its functionality. Then, defining the scope, what specific parts are you testing.
Okay.
Next comes applying specific testing techniques. Things like equivalence classes, grouping similar inputs.
So you don't test every single possible number, just representative one.
Right. And boundary value analysis, testing the edges, like
Yeah.
minimum and maximum allowed values, maybe some error guessing based on experience.
Okay, applying standard testing strategies.
Then you plan your specific input parameters very carefully,
Yeah.
execute the tests you've designed, and this is critical. Compare the actual results you got back with the results you expected beforehand.
Now, people often hear about unit testing, too. How does API testing stack up against that? Are they the same thing?
That's a really common question, and no, they're quite different. The article makes some clear distinctions.
Okay.
Unit testing is usually done by the developers who wrote the code. They test individual functions or units of code in isolation.
Got it. Little building blocks.
Exactly. API testing, on the other hand, is typically done by testers. And they're looking at the end-to-end functionality of a system or a major component through its API. It's about how those blocks work together when called from the outside.
So developers test the bricks, API testers check the wall.
That's a great analogy, yeah. Developers usually have the source code for unit tests. API testers often work without it, like a black box.
Okay.
Unit testing might sometimes touch the UI, especially for front-end components. API testing, by definition, it focuses purely on the interface itself.
No screens involved.
Yeah. And the scope is different. Unit tests are narrow, focused on basic function correctness. API tests are broader, looking at functional issues, integration, performance across multiple units.
And when did they happen?
Unit tests happen very early, often before code is even checked in. API testing happens later, usually after a build or version of the software is deployed.
That distinction is really useful. So API testing is more about the bigger picture, the system integration. Now, the article also mentioned other methods of API testing, maybe beyond just functional checks.
Yeah, it did. There's something called discovery testing. This is often manual, where you sort of explore the API.
Like just poking around.
Kind of, yeah. Do you list things?
Yeah.
Can you create something, delete it? Just getting a basic feel for what the API offers and how it behaves. It helps build understanding.
Interesting. What else?
Then there's usability testing, but for APIs.
Usability for code.
Yeah. Is the API easy for other developers to understand and use? Is it well documented? Does it integrate smoothly with other platforms? It's about the developer experience.
Huh. Never thought of API usability before. Makes sense, though.
Absolutely. Then critical stuff like security testing, checking authentication, who can call this API. Is sensitive data encrypted properly when it's sent back and forth?
Super important.
Definitely. Automated testing is huge, obviously. Writing scripts to run tests regularly, catching regressions when code changes.
Standard practice for efficiency.
And finally, documentation testing. Is the documentation accurate? Is it complete? Clear. Poor documentation makes an API incredibly hard to use correctly.
So checking the manual is part of testing the product. Okay. With all these different angles, are there any best practices the article recommended for actually doing the testing?
Yes, several good ones. It's just grouping test cases by category keeps things organized.
Logical.
Always clearly state which API is being called at the start of your test case. Be explicit about the parameters you're choosing and why.
Okay.
Prioritize the API function, calls test the most critical ones first or more thoroughly. Make sure each test case is self-contained, independent.
So one failure doesn't cascade and make others fail.
Exactly. Avoid that test chaining the article warns about, where test B relies on test A passing, makes debugging a nightmare.
Right.
Be extra careful with one-time calls, like delete functions. You don't want your test accidentally wiping out important setup data.
Good point. Handle with care.
Plan the sequence of calls if order matters. And try to create test cases for all significant input combinations to get good coverage.
That sounds like it could get complex quickly, managing all those combinations. So with all this effort, what kind of nasties are we actually hoping to find? What bugs does API testing typically uncover?
Oh, a whole range of things. A big one is failing to handle errors gracefully. Like the API just crashes or gives a useless error message instead of explaining what went wrong.
Frustrating.
Very. You might find unused flags or parameters, sometimes duplicate functionality across different API calls, or even missing functionality that was expected.
Inconsistencies.
Right. Reliability issues are common finds. Maybe the API server connection drops, or responses are just way too slow sometimes.
Performance and stability critical.
Absolutely. Security vulnerabilities, of course, improper access control, data leaks. Multi-threading issues can surface, where the API messes up if lots of calls happen at once.
Ah, concurrency bugs.
Yeah.
Nasty.
Performance bottlenecks, consistently slow response times under load, incorrect or unclear error messages, problems handling valid arguments correctly, surprisingly.
Even when you give it good data.
Yep. And finally, getting back response data, like JSON or XML, that's just structured incorrectly, malformed.
So it covers everything from outright failures to subtle inconsistencies and security holes. Now, how do teams manage this, especially the repetitive parts? Automation must be key. The article mentions some tools.
Yes, automation is essential for making API testing practical at scale. The article specifically highlighted ReadyAPI as a popular commercial tool.
Okay, what does it do?
It's presented as a pretty comprehensive platform for functional testing, security scanning, and even load testing of APIs, whether they're REST, SOAP, GraphQL, various types. It also helps with service virtualization, like mocking APIs that aren't ready yet.
Sounds versatile. What kind of features make tools like that useful?
Well, things like easy integration with development workflows. ReadyAPI was noted for its smart assertion feature, making it easier to validate complex responses.
Okay.
Support for things like Git for version control, Docker for running tests in containers, integrating with CI/CD tools like Jenkins or Azure.
So it plugs into the whole DevOps pipeline.
Exactly. Command line execution for automation, running tests in parallel to save time, features that help you reuse test steps or code, and ways to manage dependencies during testing.
Gotcha. The article also gave a quick nod to other tools or libraries.
It did, yeah. Mentioned things like REST Assured, which is a Java library, Postman, which is very popular for manual exploration and automation, and UFT, formerly QTP, another commercial tool. So ReadyAPI is one option, but there's a whole ecosystem out there.
Good to know there are choices. But even with tools, API testing isn't always easy, right? What are some of the main challenges testers run into?
Definitely. The article points out a few key ones. Just managing the sheer number of parameter combinations can be tough.
We touched on that.
Figuring out the right sequence of API calls to test a specific workflow is another puzzle. And since there's no GUI,
Right, no visual feedback.
it could feel more abstract. Validating the output can be tricky, especially like we said, when the real impact is in a different system, like a database update.
Requires broader system knowledge.
Yes. Testers really need to understand parameter selection, categorization, how the system should behave. Testing the exception handling, the error paths, can also be quite complex to set up correctly.
And does it require coding skills?
Often, yes. The article notes that, particularly for automation, testers usually need some level of coding ability to write and maintain the test scripts effectively. It's a more technical discipline than, say, manual GUI testing.
Okay. So it demands a specific skill set. Wrapping things up, the article really hammers home the importance of API testing. Why is it seen as so non-negotiable now?
Because fundamentally, APIs are the business logic layer for most modern applications. They're the engine room.
Where the core work gets done.
Exactly. If those APIs aren't tested thoroughly, you can have major problems, not just in the application providing the API, but in every single application that consumes or calls that API.
Ah, the ripple effect again.
Precisely. So getting API testing right is just indispensable for building reliable software today. It underpins everything else.
Okay, so let's recap this deep dive then. API testing. It's all about checking the functionality, reliability, performance, security of those crucial software interfaces.
The connectors.
It's different from looking at the screen. It's about the logic underneath. It needs careful test design, thinking about inputs, outputs, side effects, the whole picture.
Right. And understanding the concept.
Well, yeah, it has its challenges, complexity, the need for technical skills, but it's absolutely vital for ensuring software quality in our super connected world.
And that actually leaves us with a thought, maybe for you, the listener, to chew on.
Okay.
Think about all the invisible interactions happening constantly on your phone or computer. Checking the weather app, that's APIs talking. Making an online payment, APIs again. Booking a flight.
Pretty much everything connects to something else.
Almost everything. Each interaction relies on these APIs working correctly, reliably, securely. So the question is, what are the hidden consequences when these invisible connections fail or falter? And how does this practice of API testing act as that essential safeguard in our digital lives?
Yeah, something to think about next time you tap an icon on your phone, what's really going on behind the scenes, and who's making sure it actually works. Fascinating stuff.